Good afternoon, everyone, and welcome to the first webinar of our MESEO project. Thank you all for joining us today. It's a pleasure to have you with us. It is 5 o'clock, so we'll start right on time. My name is Jessica, and I work with Resolvo, who is the partner responsible for communication activities in the MESEO project. MESEO is a project that's co-funded by the European Union's Horizon Europe programme. And our aim here today is to introduce you to the project, to tell you some about the innovative and ambitious initiative that we are currently implementing, which is seeking to improve how we manage, process and extract valuable information from the data delivered by Earth observation satellites. As you may know, satellite data plays a crucial role in everything from climate monitoring to disaster management, and MESEO is all about enhancing how we handle this data in order to maximise its potential. Now, people are just coming online at the moment because we did start right online, so I see more people coming in as I speak. So before handing over to the speakers, I'd like to give people a little bit more time to get online. I would also like to remind those of you that are here that this webinar is being recorded and it will be made available on the project webpage and the social media for anyone that wants to watch it again or share it with their friends. So as people are coming online and before we get started, I would like to just see who is out there in the audience. So we're going to have a short poll that I'm launching now, just to find out what is your relationship with Earth observation. You should see it on the screen now. And you can write to me on the chat if there's any problems, but I hope it's there. And you can click the answer that best applies to you. Are you an Earth observation expert? Or are you an interested observer like myself? So far, I'm seeing that we're having a mixture of the people that have answered so far. 8 out of 10 are interested in Earth observation, but not experts. But we do have a couple of experts in the room, so that's good. We've got a mixture, and luckily, we have two fantastic speakers here to tell you about the project, and they can make it understandable to experts and non. So I will tell you a bit more about who these speakers are. You can see them on the screen in front of you here. Our first speaker is Amaya Tentia. She's the Synergy Coordinator for 3 projects. So in addition to being involved in the MESEO project, she also works on 2 other Horizon Europe funded projects, Leon Segs and Domino E. And Amaya will introduce to you both MESEO, but also the interconnected relationship between these different European projects and their approaches to Earth observation data and management. Our second speaker is Paloma Fonseca, and she is our MESEO project coordinator at GMV. GMV is the coordinating partner of MESEO, based in Spain. And Paloma will build on Amaya's presentation with a more in-depth overview on MESEO, highlighting its key features and the innovation that we're designing and testing to improve service quality, timeline responsiveness across the end-to-end Earth observation chain. Just before I pass over to Amaya, I would just like to say that after each presentation, we'll open the floor to your questions from the chat, so the written questions. You write them down on the chat function at any point during the talks, and then we'll address as many as we can during a short question and answer session after each presentation. That's all from me. It's time to pass over to our experts. So Amaya, the floor is yours. Amaya, your microphone is muted.
So, hello, good afternoon. Thank you very much, and thank you very much for your interest and attending this first webinar of MESEO. We are very excited to present to you some in-depths about this project that we consider strategic for the development of EO industry and EO capabilities, especially in Europe, with a global impact all over the world. So as Jessica explained, I am going to provide to you an overall vision of why MESEO, which is the context of MESEO. We could benefit of having these capabilities, and also which are the synergies between the different projects that are running in parallel, that are co-funded by European Commission, that are dealing with the question of federation and data security and sovereignty and multi-mission and multi-constellation aspects. So I will start by introducing 7 main points, 7 main critical challenge of the reason of MESEO, why MESEO exists. As Jessica has introduced, MESEO is designing and will prototype and demonstrate a solution that it is open, flexible, and scalable, and it is applicable for multi-mission Earth observation end-to-end systems, and particularly the part that in which we work in MESEO for these end-to-end Earth observation systems is the satellite data processing from onboard, from the satellites to the downlink and to the ground segment, especially ground segment and onboard solutions. So we are aimed to solve to deal with a critical challenge that have to do with some of the points that I am going to explain to you now. The first of all is the performance bottlenecks in the EO system. Nowadays, with the existing EO systems, we are facing significant bottlenecks, especially in the space sensor acquisition, in the image downlink speed and capability, and also with the time of ground processing that is very, very related with the allocation of the data. So to the access to the data, to the movement of the use of this data or the movement of this data from one place to another in order to be processed. So MESEO aims to optimize these bottlenecks, identifying which are the points of the bottlenecks and solve this by using innovative design and advanced state-of-the-art technologies. Another challenge is to provide this capability of scalability and flexibility that it is tremendously necessary because of the diversity and the amount of different EO data sources, EO constellation that more and more are growing in number and complexity. So having a solution that has the capability to scale in the number of data and scale and be flexible to include new constellations and new data sources is a paramount for this future. So we are developing this multi-mission capability, let's say, and by being based in this concept of open, flexible, and scalable solution. And this is very linked to the implementation of a modular and loosely coupled architecture for this solution, making use of the paradigm of the function as a service. So this will provide a dynamic adaptation, therefore flexibility to new elements, and will provide an efficient scalability to deal with the increasing number of items. Another challenge that it is very important in the context of EO European space is the data sovereignty and the security. It's important because the number of constellation of data sources that will be accessible through this solution may come from different sources that have to do with different rules and different privacy, security concerns. So the solution the cybersecurity solution must be capable of integrating all these components in order to protect this amount and diversity of EO data and to maintain the sovereignty over these data transactions. This is solved by developing a trusted and secure environment that will deal with the managing and this data transaction on the cloud, including elements of data integrity and preventing unauthorized access to this data. Very importantly, for MESEO is to provide a solution to enhance the quality in data processing. Quality is a multi-phased concept, so MESEO will deal with the quality of service by providing with solutions by providing solutions on board that will have the capability to include artificial intelligence models that will improve the data handling and reduce the data latency. So focusing with this solution on board will enhance the capability of providing top quality services, especially for those services that requires of near real-time reaction times. It will reduce also the communication bandwidth, that it's quite an important issue in the download of data, and also incorporate new technologies for the onboard power consumption and processing capability, as I said. So all this optimization on board will provide real-time insights to these potential EO services. Very importantly, why of all this need to access to a diversity of data, to make use of different sources, to make use of different constellation and to gain of the capability of the different sensors on board, because this is very important to contribute to European Green Deal objectives. So all this technology that we are developing here will be used in the future in applications that has to solve this big challenge of European Green Deals. And in this particular case of this phase of the project, we are developing two use cases, two applications. One is the methane monitoring, and the other is the crop classifications that are directly contributing to the objectives of climate neutrality and sustainability and sustainable agriculture. But besides the technology improvement, with the aim of providing this crucial EO service to the society, this activity, MESEO, also improves two other aspects that has to do with the market competitiveness and innovation, and with the engagement and of stakeholders in this platform. So the MESEO will demonstrate its innovations through the pilot service, and will provide this and will enhance the Europe leadership in the worldwide EO market by fostering innovation and creating this collaborative ecosystem of EO service providers. This will drive economic growth, reducing operational cost, improving service quality, and opening new market opportunities for EO data and services. Finally, MESEO will promote this collaborative digital platform ecosystem that will enable a diversity of stakeholders that includes not only the traditional Earth observation industry, but also the new space player to register and the capability to offer their service to this ecosystem. The comprehensive communication and dissemination activities like this, and also the definition of the exploitation plans that are part of this project will ensure that the innovations will be widely adopted and integrated in the market. So in summary, MESEO is essential for advancing the capabilities of EO system, ensuring data security, supporting environmental sustainability, and maintaining Europe's competitive edge in the global EO market. This is a list of keywords that are related, the hashtag slide related with what it is MESEO about. So MESEO is a synonym of multi-mission, federation of constellations, enhancement of performance for processing, developing a collaborative digital ecosystem, and providing a secure and trusted exchange of data that fulfills with integrity, confidentiality, and sovereignty objectives. And also, and quite interesting, is that MESEO will also contribute to the space data space. The space data space are digital infrastructures that are secured and standardized and enables the capability to exchange data in a trusted way and to develop data-based services in this making use of this data, and with the collaboration of different stakeholders that are registered are part of this space data. And importantly, is the governance of the space data space that is based on sharing for all of these stakeholders the same policies and rules. This is very important for Europe currently, and with the objective of enhance the production and the provision of data-driven products and services across a market in Europe, and making an interconnection of different data spaces. In this sense, MESEO is not a complete data space itself, but it integrates the principles that has to do with secure data exchange, data sovereignty, and the development of collaborative framework for data processing and data management. Therefore, MESEO could be the technology of MESEO could be part of future data space, which is also very important. And this is a definition of we will use of MESEO technology, and we have different levels of future users. So institutions and regular bodies will benefit of this technology. They are responsible for providing information for decision makers, and they are responsible for making use of EO data for monitoring the compliance with different regulation, like the environmental regulation. So institutions and regular bodies. Of course, the industry and public institutions that provides EO data, and are also processing centers, because this technology can be integrated in these processing centers, and also integrated in future data space-based solutions. And finally, the future industry, the new constellations and the new space players, those that are building new constellations, building new satellites, and also those provider or solution that provides an integrated vertical solution from the satellite to the ground segment. My final slide is, as Jessica mentioned, is just to show you some of the ongoing projects that are co-funded by the European Union, all of them managed by the Health and Digital Executive Agency of the European Commission, and all of them have shared different solutions and share different utilities and capabilities for this future ecosystem of EO data constellations. The harmonized interfaces, the creation of a central, automated, and multi-mission services, the definition of a ground segment that it is automated, scalable, and flexible, and of course, again, multi-mission, multi-constellations. The sustainable EU collaborative new space low-cost ecosystem, very important for the development of the EO industry in Europe. The provision of a mechanism that it is automatic and end-to-end in provision of EO data, and finally, very importantly, the enhance of EO players, enhance the leadership of the EO players worldwide. So I hope this introduction is clear for you. We will go to the explanation of the project by Paloma, and in the finalization we could answer all the questions that you may have. So thank you very much for your attendance.
Thank you very much, Amaya. If you don't mind, I'll ask you just to answer a couple of questions already, because there are already some questions on the chat for your specific presentation. So first of all, you used the term function as a service.
Yeah.
Could you please elaborate slightly on what this means exactly?
Yeah, function as a service. Thank you for the question. Function as a service is like a catalog of functions. In the data processing, we use different type of functions for manipulate and transform data to provide the final products. So make transformation. And these are algorithms, so are steps one after the other or running in parallel. And traditionally, these are all of them an unique processing element. So that we will call this in this context, a function is a processing algorithm. And normally, traditionally, they are running in a centralized point altogether, so with a organized step and in a processing framework. With this function as a service, we have a catalog of different functions, different processing functions that deals with different parts. So we build, and each function can be developed by different entities. When we have the need to define a new product, we can take different functions of this catalog and to order them logically to provide the product. And these functions can run in different places. So they don't need to be centralized, running in a single platform, but they are like divided into pieces that each piece of it run in a different data source. And the condition is that we have this catalog of functions that fulfill with a number of rules and policy and with some standards. So it provides a great flexibility to define new products, and also this catalog can be increased in number with more functions and more complexity.
Thank you very much,
It is
Amaya.
clear.
Yeah, I think so. I hope that answered the question. One more question before I pass on to Paloma. You mentioned among the users of the MESEO system, you mentioned new space players. Could you give just some short examples about who they are? Who might they be, these new space players?
New space player is a new constellation builder. So typically, in the new space, there is not a unique definition for that, but in the context that we use new space here is for companies or in private companies that wants to develop a constellation of satellites that may be developed and launched and operate into space in a low cost basis. So is this democratization of the use and development of space. So having this type of solutions will benefit these companies because they could access to existing solutions and to put them into operation in a quick and low cost way.
Okay, thank you so much, Amaya. We do have a third question on the chat, but I think that Paloma will probably address this in her presentation because it talks about what mechanisms can be used to secure and maintain data sovereignty. And Paloma, I think you probably will talk about that in your more detailed presentation of the project. So I would pass the floor to Paloma. You can share your slides and start your presentation. And if this question isn't answered during the presentation, we'll address it after that. Over to you, Paloma.
Perfect. Good afternoon, everyone. I think I'm showing the right slide. Is this correct, Jessica? Yes, no?
Yes, I can see it. Yeah.
Perfect. Thank you. So just to wrap up a few ideas of MESEO. MESEO is a collaborative research project involving 9 partners and funded by Horizon Europe program. During this session, what we want to present you MESEO, the topics that are listed in this agenda: who we are, the project summary, the project result, the use case that we are using for the demonstrator, and a few takeaways in the conclusion section. In the context of Earth observation, where the amount of Earth observation data is very high, both processing and the treatment of this information should be faster in order to meet the user needs. In this sense, MESEO has the objective to improve quality of service, timeline reactivity at different levels and processing ages, ensuring space data sovereignty. And in order to demonstrate this concept, we have chosen, as Amaya mentioned, 2 Green Deal applications for the demonstrator. Who we are? We are a consortium of 9 members covering technologies from onboard to on-ground segment. For example, from the onboard segment, we have Satlantis, who is in charge of the payload prototype, and also they are in charge of coordinating the onboard activities. Ubotica is the main partner for the edge processing with AI in onboard segment, and Creotech is in charge of the innovation in the satellite platform. On the ground segment, we have GMB, and we are coordinating at system level, and also we are designing and prototyping the ground function. Sovereignty will be in charge of the data sovereignty, and we will see that they are placed in between the the distributed components. Airbus, who is in charge of the analysis and the specification of the components that cover the space data sovereignty. And also they are verifying the interfaces so that we meet the security requirements. For the Green Deal application, we have two partners, Unifi and Sistema. They are providing us the processor for the use cases, and Sistema is coordinating the pilot demonstrator execution. For communication and dissemination activities, we have Resolvo. Here is Jessica one example. And we also have an advisory board members who will be engaged through the project in order to give us feedback on two perspectives, for the end user perspective and also for the ecosystem player. Up to now, what we have done is to analyze the Earth observation satellite system in order to identify the bottlenecks in performance and also the areas of improvement in the processing chains. With these findings, what we have done is design a system based on function as a service, that they will give us the support us in helping us for the improvement in the processing chains. In the end-to-end architecture, we will have an A coordination center and multiple distributed components that they will expose their functions in order to combine them and produce the processing chains. So the objective of a coordination center will be to orchestrate the different components, the different distributed components. Also, the coordination center will be in charge of activating the optimal end-to-end performance to fulfill the user requirement. The coordination center also has the role of registration this function as a service, and will be able also to will be also able to produce the thematic products that are required by the user. If we go in depth of the processing chains, we have the design is they have different building blocks, and on top of these building blocks, we have the sovereignty component, who will be running in a transparent way, with harmonized data sovereignty protocol. We also are identifying system security requirements. And a subset of these system requirements, we are implementing the sovereignty data. On the onboard segment, we are going to enhance, our objective is to enhance in timing by applying optimized handling and storage, and also applying AI-based preprocessing. For the on-ground segment, we have multiple levels of processing, and we aim to enhance in quality by applying AI-based processing and also data function. Two main aspects we want to cover in the MESEO project, which are the data processing and the secure services. For the data processing, as mentioned, we have geographical distributed components. They are coordinated by a central EO coordination, and we will use harmonized interface in order to expose the function. For the related to the security services, integrity and confidentiality of the data will be addressed in in the analysis risk that we are doing to the system, and also an innovative data sovereignty mechanism will be used through metadata attached to the data. We have selected two use cases for the pilot demonstrator, one related to methane monitoring emission, and the other for crop classification. The demonstrator is split into phases. We will have one early prototype with early scope, and at the end of the project, we will enhance this first prototype. It will be run, the prototype will be run in laboratory. So part of this simulator, of this end-to-end processing chain will be emulated. And to wrap up the presentation, just a few takeaways from the MESEO project that are: MESEO is a federated and flexible and scalable age processing system. Our primary communication method is function as a service. MESEO is a distributed component, and we aim to improve the service quality and timely reactive at various levels by ensuring data sovereignty, and two green applications have been used for the demonstrator. And this is all for my side, Jessica.
Thank you very much, Paloma. Thank you for this overview of our project. Please continue posting your questions on the chat. We do have one that was sent to us, which, Paloma, I will read to you. It says, I would like to know a little bit more about the pilot demonstrations. For example, crop classification. What kind of improvements would you expect in this case? Now, in fact, these pilot demonstrations will be the main topics of our next two webinars. I'll just do some publicity here, which will be organised at the early next year. But for the time being, perhaps, Paloma, you could give us an initial answer to this question. What kind of improvements are we expecting, for example, for crop classification?
Yes, for example, for you, maybe the person who asked knows the difficulty of an artificial intelligence model to perform this crop classification, because it is a very complex task, because it requires a lot of processing and analysis of a large amount of data. For this, yes, we are going to base in neural network for this deployment, for this performance, so that they can perform this analysis. And right now, what we are doing is identifying the preprocessing dataset for training the algorithm.
Okay, thank you very much. So everybody that wants to know more about crop classification should join us at the beginning of next year. And in the meantime, a second question. So this is about terminology. You use the terms processing and treatment of information. Can you explain exactly what differentiates these? What is the difference between the processing and the treatment of the data? Either Amaya or Paloma, whoever wants to answer that one.
May I can answer that. Processing, as I said in my first response, has to do with the transformation of the data. So you get an image for a sensor that it is on board a satellite, and you have to make some corrections due to the Earth geometry, to the effect of atmosphere, and also in addition to the corrections, you want to extract information out of this image. For instance, you want to count the number of trees in an area. So you set an algorithm to distinguish, identify the trees, and count the number of it. And therefore, this is the processing, is the transformation of the image with the aim of obtaining the information that you need, or with the aim of providing an image that it is corrected, as I say, geometrically, atmospherically, in order to be used, to be analyzed by a scientific or another person. This is a processing. But for doing that, you need data. And in this data, with this data, you need to access, maybe cut the image into pieces, store it, obtain metadata, catalog. So this is the other part of the data that you have to move, and you have to treat this data in order to be useful to be processed. I don't know if this is clear. Okay.
According to the comments on the chat, it is very clear and helpful. And just the follow-up was if all the applications are based on image processing, so it's focused on images.
Yeah.
Yeah. Okay. Thank you very much. Do we have any other questions from our participants here today? Earth observation experts or less experts? We welcome questions from both groups. Okay, I'm not seeing anything coming in at the moment, so I will just pass the floor quickly back to Amaya and then to Paloma for just any final words that you would like to say about the project, about the projects, because of course we talked about MESEO, but we also mentioned our other sister projects. Any final conclusions? First Amaya and then over to Paloma.
Okay, thank you very much. Maybe there is another question.
So there is. About data sovereignty, you mentioned metadata attached to data, and this is presumably critical. Could you explain any further about that?
Okay, this is a little bit more technical, and the metadata is this information about the image that you use to know what it is in the image. When it was censored, which area it covers, the orbit of the satellite. So this metadata provides you with the information that you need to look for the adequate data that you need to use. And also, once you transfer the data, you add more data to say which is the elements that. So it's like the language to describe the image, and what is needed to use these images. And the security is different in the sense that the data sovereignty and the data security in this project is based on the use of a number of interfaces, some interfaces that provides a method to use to access in a secure way to this data, so that this access is trusted. So it is not possible to access to the data without being sure that the element or the item that wants to access to it has the privilege and that it is going to be correctly managed. So are different things.
Thank you so much, Amaya. So our comment on the chat is it's like a key. You can't use the data without this key, which I think it
Yeah,
sums it up.
exactly, like a key.
We have one other question which I would like to put to Paloma that's come up on the chat to us organisers and speakers, saying this is so exciting. Thank you. I agree. I think it is. And for people coming new to Earth observation, do you have any careers advice in terms of the critical skills that somebody might want to learn in order to contribute to a project like MESEO? Now, MESEO has a multi-sector, multi-skilled consortium, ranging from, you know, what you saw before, the people doing communication, and then the technical parts on the ground, on board, the data, the algorithms, the artificial intelligence. Paloma, what would you say to somebody that, you know, is coming up through their education? What kind of critical skills could be required?
As you mentioned, we are multidisciplinary consortium, so anyone can fit in, no? From the onboard segment to the on-ground segment, AI processor, everything, everyone is involved, and anything that it's related to Earth observation could fit. Thank you.
Okay. So thank you to all of you. I'm not seeing any more questions on the chat for the moment. So I would like to say then it's probably almost time to let you all to go home. So thank you again for joining us today, for listening and for all your questions. We hope that it's been useful, that it's given you some new knowledge, not only about the project, but also about, let's say, the importance of the topics that are being dealt with. So, you know, the question of how we use space data and what's it for and how it can be applied to challenges that we're facing, such as these environmental climate change monitoring. We hope that we'll see you again. As we mentioned, we will be having some more webinars in 2025. More information coming soon, but we did mention, of course, earlier that they will be focused on these two user cases. So the methane detection, Earth observation for methane detection and assessment, and for crop classification. So we will really be going into detail, not just about the sort of technological architecture, but about how this can be applied and tested. Please also take the time to visit our website and social media. The links are in the chat, so you can click on them there. There's more information, there's some videos, and coming soon also a wonderful science communication podcast directed at children, so explaining MESEO in even more simple terms, the kind of terms that I understand. So that will be a new instrument on our website. So that's all from me. Goodbye. Thank you again, and we look forward to seeing you again very soon.
Thank you very much.
Thank you. Bye.